in one 24-hour period with about $50 worth of hash power. This could knock over about as much as my CPU could do if it was running for 3 years straight. This video is just going to run through how to use Vast.ai with BTCRecover, because I get a lot of people who contact me looking for help running BTCRecover, and their main issue is they simply don't have a computer to run the tool on. Maybe their CPU is old and not very powerful. Maybe they've only got a laptop that's shared with their family or whatever. What I'm going to run through in this video is how to use Vast.ai, how to set it up, and how to use it for both Bitcoin Core and blockchain.info password recoveries in a secure way, because there's actually some features in BTCRecover which make it very easy to do a fully secure password recovery using rented resources. And if you haven't already done so, hit subscribe, and that way you can stay in the loop for content I make to help you find your way in the crazy and often hostile environment that is cryptocurrency. So this video is just going to run through the usage example that is on the BTCRecover GitHub, and the clear thing I need to say at the beginning of this one again is that this process is really not going to give you a huge boost for BIP39 seed-based wallet recovery, and it's actually not secure to do this for a BIP39 seed, in that the person you are renting the hash power from could actually record and keep the seed information you're putting onto their server and could rob you. Whereas with Bitcoin Core, with blockchain.com, we are going to be doing it in a different way, which keeps it secure. So what you're going to need for this is you're going to need some secure shell software, SSH, and I'm just going to use Putty on Windows. I'll also run through how to use WinSCP for this, just because it's handy to be able to copy your token list around, and because you will actually need it to copy the autosave files. You can't easily just move them backwards and forwards in Putty just with copy paste. You're also going to need a credit card and a Vast.ai account. So the first step for both of these wallet types is to create a wallet extract. Now you could do this on your home PC, or you could do it on a separate Vast.ai instance. So if you're running this on Windows for Bitcoin Core, you're actually going to need this module here. If it's just blockchain.info, you're not going to need this, but I'll just quickly run through how to install it. We're just going to follow the instructions here and scroll down to the Bitcoin Core, and we're just going to go to this website here and get a copy of this file that matches our environment. Let's see. So I'm running Python 3.8 on a 64-bit environment, so I want this one here, which is for Python 3.8. AMD 64. So I'm just going to click on that and download it. And that's just going to have gone into my downloads folder by default. So I'll just exit this and we'll just go into downloads. And what we're going to say is pip3 install, and then we're going to type in the file name that we just downloaded, which was this one here. And if I just start typing that, stdb, and hit tab, it's actually going to auto-complete. That's the one. Hit enter, and if everything's worked, there you go, successfully installed. So now we're ready to go. So we'll go back to the doco. So we'll just navigate to wherever you've got BTCRecover unzipped. So for me, that's just in my GitHub folder. And we're also going to navigate into the extract scripts folder for this one. And if we look in the extract script folder, you can actually see all the ones for different wallets in there. So basically, we're just going to use this command here. And we're going to call it for Bitcoin Core, and we're going to use the Bitcoin Core wallet that comes with the repository, just for this example. And if we hit enter, you'll get this message here, which says partial, Bitcoin Core encrypted master key, salt, it account, and CRC. So this is the string that we're going to use with BTCRecover. And you can see that's the same as the one that I've got in the documentation. So if you're using this repository and reproducing this, that's what you should get. So the next step is we actually just want to create the token list file and work out if a server is actually required. So you can do this just on your PC. So in this example, I'm actually just using the data extract string. You'll notice that's the one we just created before. And I'm just putting that straight into the commands. I'm saying I'm going to use a token list, and this is the path to the token list that is bundled with this GitHub repository. The token list for this one is just in the docs folder under usage examples, multi-GPU with Vast.ai, and that's this token list right here. So it's just got 11 rows, and I've basically just broken up the word that it's looking for deliberately so that it will produce about 50 million possible outcomes. There's no anchors of any kind in here, and it's deliberately been structured so it will find the password at the end of the run. It's probably a good idea to run it and go through the counting password step just on your PC just to work it out. And so there you go. So, around 50 million. And we can see that would take about 15 hours on my CPU, about 1.5 on my GPU, and about 10 minutes on the 10 times 2080 Ti's. So that's spread across 5 Vast.ai instances. So I'll just cancel that because we don't need to run it here. Basically what we're going to be doing is we're going to use this same command essentially in terms of the data extract string, same token file. And on the servers, we're going to have one command for each one. And all these do is basically the same stuff that we have here, except it starts with Python 3 because that's what you need in Linux. We're going to suppress the security warning. We're not going to worry about counting the number of passwords because we've already done that. So these servers will start working straight away. You probably also just want to say no dupe checks because generally, particularly if you're doing a big run, you're going to start hitting memory problems probably. Anyway, so you might as well just do that. And we're going to enable GPU using the Jack the Ripper kernel, and we've also got some other parameters that will work pretty well for just about any NVIDIA system. I'm also going to turn on autosave, and I'm going to use this worker command. So you'll notice we're going to say 5 total workers, and then each of the servers is going to have a slightly different worker command. But other than that, the command will be exactly the same. And because the token list I'm using is actually part of the GitHub repository, we don't need to worry about copying it and pasting it onto the server or using WinSCP. So that brings us down to the open Vast.ai instance settings. So we'll just head over to Vast.ai, and we'll just get rid of that. So if we click on console, if you're logged in by default, it'll actually take you to this screen. That is the create screen. And you'll notice there, I've actually already got credit on my account. All right. So you will need a few bucks of credit before we do this. So what we're going to do is, firstly, we want to make sure that we're using the operating system image that I've listed here. But generally speaking, if in the future you can't find these OpenCL ones, generally any Hashcat image will work too. But anyway, so what we're going to do is we're going to click over here. We're going to say edit, image, and config. And rather than this AI research one, we are going to select the NVIDIA OpenCL one. Or you could literally just paste it straight in there. But I'll just show you this anyway. So you just select the official NVIDIA one, and the runtime image for Ubuntu 18.4 is the one we want. We want it to run as an interactive shell server with SSH, and the on-start script we're going to put in is this one here. So basically this on-start script installs everything you need for BTCRecover. Like it'll update the operating system, it'll install Python, it'll copy BTCRecover onto the server, it'll install all the requirements, set the locale so that it will work, and it also just changes some stuff so that tmux, which is the Vast.ai thing over Secure Shell, will work properly with Putty. Honestly, this doesn't matter for this video, but it does mean that if you want to run multiple things on the same server, you can sort of page between different screens. But again, that's beyond the scope of this video. But generally, if you're using Putty, you probably want that too. So we'll just set the space to allocate down to just 1 GB, which is loads for this sort of recovery. And we'll just say select. And now that instance configuration is there. In terms of max instance duration, depending on how long you want to run this for, you might want to set that to be a few days or even a few weeks. Most hosts don't seem to have it. I don't worry about including external offers. So we'll just go down. And for this video, we'll just look at ones that have a GPU count of 2. Though you might want to have more than that, but we'll just stick with 2 for the minimum. All the other defaults are pretty much fine. What we're doing doesn't actually need a lot of bandwidth either, so you could turn the internet requirements down, but honestly, that's not going to make a huge difference to what's available. So over here on the right, these are all the servers that are available for us to rent, along with their price. So for this one, we're going to run it over 10 GPUs spread over 5 instances. So that's going to be about 1,000 times faster than my i7. So we'll just get some of these ones with 2080 Ti's. They're all a similar price. And what will be available will depend on what time of day you try this and what other people are doing. So I'm just going to rent these 4 and what else is available? So, so there's another 2 times 1080 that are a bit more expensive. They're only $390. Oh, hello. There's a 3. We'll give this a go. Get some 390s as well. So we'll just rent those and we'll see if they work. So anyway, that'll be fun to check. So if we head over here to instances, you'll actually see now that we have 5 of these servers that are all initializing and doing this status. So they're basically just loading it. And what we want them to do is to get to this state here where it says successfully loaded the runtime, which is good. And then we're just going to need to give it another minute or 2 as well, just to run through the install script that we told it to do. All right, so while those are going, it's also a good time, if you haven't already done so, to set it up so that you can SSH onto these machines. So if you go into your account page, we're just going to set your SSH key. So this is going to be what you use to authenticate with all of these servers. So we're going to open a program called Putty Gen. It would have come with Putty, and it's going to generate some keys. So we're just going to say, leave it all in the default, just say generate, let that happen, and there is our key. So I'm actually just going to save that one, and I'm actually not going to worry about putting a passphrase on it simply because I'm only using it for these Vast.ai jobs and because it saves me typing it in the video. I'll just say no for now. You probably want to put a password in here just so that any random person with access to this file can't just authenticate and log into your Vast.ai services. But again, for the purposes of this video, I'm just going to leave that blank and save it. And we'll just call that Vast.ai and just stick it on the desktop. Again, you can stick it anywhere on your PC. All right, so we've got it there on the desktop. And the other thing we're going to do is we're going to copy this whole block of text from up here from Putty Gen, and we're going to put it straight into Vast.ai there. And that's the SSH key that we are going to use. So basically telling Vast.ai to trust the certificate that's in this file. So we'll go back into instances, which will have all those instances we made. We don't need Putty Gen anymore. So what we're going to do is we're going to just say connect on the first one, and we want this piece of information here as the host name, and we'll leave the username on there too. You want that, otherwise you'll be prompted for it. We're going to use the port, which is this one here. We're also going to just give that, we're going to click on the SSH button near the little plus, go to auth, and we're going to select that file that we just created. So that's the private key we're going to use. And we'll go back up to session, and we'll just call this Vast1, and we'll hit save, because we're just going to copy that for all the next ones. And if I say open, it'll prompt with this message here, just because my computer doesn't recognize it. You will always get that the first time. So I'll just say, yes, I want to trust that this is the right one. And it will then log in to this. So you can actually see this number here that matches this number over here. So this is the right one. And if I want to just double check that all the install script has worked correctly, I can actually just type in cat on start.log and hit enter, and it should show me that it's successfully installed all of these different things. So that's what we want. So that's good. So what we're going to do is we're just going to open up 5 of these, and then I'll paste the commands in on all of them, but we'll just create all of the sessions for them all first. So I'm just going to say load. I'll close that. I'll click connect on the second one. And now this host address might change sometimes. The port will generally always change. And then I can just change the name to server number 2 and say save. And I'm not even going to say connect. I'm just going to go through and get the information for all of them. All right, so it looks like all 5 are good and working, which is great. And I'll just quickly show you what it looks like WinSCP. So this is what you'll see when you open WinSCP for the first time. And again, we're just going to use the same settings we used before. So we'll just say new site, copy the host name in there. I'm not going to show you this for all of them just because I won't actually be using WinSCP for this video. And we'll just say advanced authentication, and then we're going to just find that private key file that we used for the other ones. And we can just save that as just number one. And if I say log in, basically what this does is it will log in using SSH and essentially set me up with these are folders from my local PC here. This is the server, and I can actually just drag and drop files between them using this. So this is excellent if you've got like a large and complex token list file that you're not going to copy or something like that. So there you go. So this is how you'd copy it, and likewise, if you had an autosave file, you'd copy it back using this tool. So that's WinSCP. All right, so we're just going to copy this command. So we'll just change the directory into the BTCRecover folder, and we'll just paste our command in and hit go on all 5 servers. Ugh. All right, so this one has a build failure. So if you get this error, most of the time you just need to destroy that server and pick another one. There we go. So that's running now on one of them because the other 2 didn't build properly. And we'll paste this into the second one, so we're up to worker 2. All right, that's going. All right, so we've got it working now on these 3 instances, which is great. And basically what we're actually going to do is we're going to destroy these first 2 because they aren't working. And we can tell easily which ones those are because it is at 0. So we'll just destroy those 2 and we'll just create some more. It'll actually remember our settings from before, which is good. Okay, so these are our 2 replacement servers. So let's just check that they loaded everything. Yep. A quick and easy way to check everything's going to work is just to use this benchmark command here. You can literally just copy and paste that straight onto any of them and it will work. And if you're in the BTCRecover folder, okay, so both of these ones are working now, which is good. So we'll just cancel the benchmark and they can be workers 4 and 5. And there you go. So you can see now we've got all 5 of these running 50,000 passwords per second for a Bitcoin Core recovery, which again is not quite 1,000 times what my CPU can do. If you look here at the performance comparison, but it's pretty close. And again, you could just chuck another 2 CPUs on there. So this will probably take about 10 minutes to run, and this would have taken about half a day on my CPU. But again, particularly for larger jobs, this could knock over in one 24-hour period with about $50 worth of hash power, about as much as my CPU could do if it was running for 3 years straight. So very, very worthwhile. And the thing with Vast.ai is that the price tends to scale quite nicely with performance, and there's really not a whole lot of reason why you would go for a cheaper machine that's going to take longer. Just while that's running, I'll also just quickly show you is how these autosave files work. So you'll notice I use the same file name on all 5 servers for the autosave file, and basically we can actually just have a look using WinSCP just to see that autosave file. Just in case you wanted to say start a job on one server and move it to another and not lose your work, or if you want to try and save money and get like an interruptible instance on Vast.ai, you could use this to be able to resume that work. So what we're seeing here is this is just the local folder that I've got that's just the tutorial folder for this video, and then this is the BTCRecover folder on this server here, which is currently running. So if we just scroll down a little bit, we can actually see this autosave file here just being updated every now and again, and basically that's the file. So if I wanted to stop this instance number 1 for some reason, maybe I ran out of credit or again it was interruptible, I can actually just save a copy of that on my computer, and that will allow me to resume it later. I can change the name, and that's not a problem either. So, and basically I could then take that and lose it and not lose this progress. And the good thing about the autosave file is it actually remembers all of the parameters that you used when you created it, and it'll generally work between computers just fine. And look, if you're feeling clever, you can actually do things like having WinSCP automatically synchronize the autosave file onto your computer, or you could have a script running on the server that downloaded it somewhere periodically and all that, but that's again beyond the scope of this video. So there you go. So worker number 5 found it, and basically we can see the other workers actually are still going because these don't communicate at all, and the others had finished. So we can just stop that on the other ones. And there is our wallet password. So that's great. So now we've got our password, we can actually just destroy all of these instances. Just being aware that if you want to copy your autosave file off before you do that, you will need to do so. But you can just destroy them once you're done, and then you will stop getting billed for them. So I'll just destroy those 5. And now they're all gone. So we'll just quickly run through how to do this for a blockchain.com or blockchain.info wallet, and I'm just going to use 2 large GPU instances for this one, which is going to be about 100 times faster than an i7 CPU. So basically, the first part of the process is the same in terms of creating a wallet extract, though you'll notice this time we're using this extract script, so we're wanting the main password for a blockchain.com wallet, and this is a demo wallet file that's part of the GitHub repository, and it will produce this extract script here. So basically we are going to use the same token list for the same 50 million passwords. That's all the same, and so we'll go find some servers. So this time we want some that have 10 GPUs each, because this actually scale, the OpenCL kernel for this actually scales quite nicely for this one. So we want to select ones that have 10 GPUs each, and here we go. So we've got one for 10 1080 Ti's and 10. So we've got 2 with 10 1080 Ti's, and just for the sake of consistency, we'll get 2 that are the same, just because they'll probably finish up at the same time. Though again, there's nothing wrong at all with just going for one that's like a 1080 Ti that has a bit more performance. This number of teraflops is a good indicator of that. So we've got our 2 servers that are being created, and we've got our settings from before. So we'll just say connect on here, and we'll copy that information out. So we'll just delete these other ones because they're not relevant anymore. All right, so we'll just say load, and the address is the same, the port has changed. So we'll say save for number 1, and I'll just close that. And for number 2, it is number 4, and we'll just change the port to match. And we'll say save. And now we can open. So we've connected to the 2 servers, and we can just check that everything started properly. That's still going, so you can actually see it's still downloading NumPy. So we'll have to wait for a few more minutes on that one. And this one looks like it's done. So we'll just run that command again to see how that one's going. So if we just keep running cat on start.log, it'll just keep showing us what's on there. Installing packages, successfully installed. All right, so we're ready to roll on this one too. So let's just go back to here. Okay, so what we're going to do on these 2 servers is we're actually going to copy and paste the token list in. So we're just going to go to the BTCRecover folder, and we're going to say nano tokenlist.txt, and that's just going to create an empty file. And we can actually just copy, so we can open it in Notepad on our computer. We can say copy, we can go here, we can just right click in Putty, and that will paste it in. And then we can just say Control X and that will exit. And we want to say yes, we want to save the buffer. We want to keep it with that name. So now, if we type in cat tokenlist.txt, it'll actually show us what's in that file, and we can see that matches what is in the token list file on our computer. So we'll just do that on the other one as well. There it is. So basically, we can now just use these two commands. So again, this is a similar command to what we had before, except we're enabling OpenCL, not enable GPU, because we're using the OpenCL brute kernel. We're also going to have 20 threads, because for this OpenCL kernel, you want to try and have at least 2 threads per GPU. And we're also just pointing to a token list file that is just in the folder that we're running this command from. So we'll just stick that on the first one, and we'll say go. So we just right click in Putty to paste. All right, that's running. And paste that there. And that is running. There we go. And it will take a little while before it starts. It'll just sit there at 0 for a sec, and then it'll start ramping up like this. And that's pretty normal. And there you go. So you can see we're running at about 100,000 passwords per second now, which is about 100 times faster than just running it on an i7 CPU. And there you go. So we can actually see that worker number 2 has found the password, and we can basically, once we've noted that down or made a copy of it or whatever, you know, just destroy these 2 servers and we are done. There's a number of things about Vast.ai which make it really, really good for this kind of thing. Firstly, the price is very low because you're just sort of renting stuff that just other people around the world are leasing out. So it's a lot cheaper than, you know, hiring GPU resources off like Amazon or something else like that. You can get it provisioned straight away, which is brilliant in that you can easily just play around with it and get going within a few minutes. The key thing with Vast.ai is all the billing is per second. So there's really no reason not to just hire a large server with tons of GPUs in it to just smash through a larger token list in the shortest possible amount of time, rather than having to wait several weeks or months to find out whether actually you're on the right track. The process in this video can be securely done using any of the extract script-based wallet recoveries that BTCRecover supports, and basically the process is the same for all of them. So the commands I'm using in this video are also exactly the same ones you would use if you're just running BTCRecover locally on your computer. So again, if you're looking to do a Litecoin Core or blockchain.com recovery and GPU accelerate that, even with one PC locally, it is still very, very, very worthwhile. And the really good thing about this is that even if you don't know how to set up a Linux environment to run BTCRecover or anything else like that, you can actually just use the instructions in this guide and the startup script to have essentially a working BTCRecover environment ready to go. So if you're trying to like troubleshoot your own GPU installation and just see what commands should work and which ones shouldn't, you can sort of have like a reference implementation that you know should work. Because again, you can just easily reproduce exactly what I've done in this video using exactly the commands here, and see that working for yourself. That's pretty much it. If you have any other issues with this or struggle getting it going, just leave a reply. And again, happy to help out if you're getting stuck, or improve the documentation on GitHub if you're running into trouble. Thanks for watching. I hope that was helpful. Hit like if you think that other people would find this video useful, and hit subscribe if you'd like to be kept in the loop about future content I make that helps people stay safe in the crypto space and to recover if they get into trouble. If you have any questions about this video or a topic that you'd like me to cover, just leave a reply.